Okay, this is our class. Look, MAC1105, Spring 2021. Do you see the Alex or no? In that moment, you see the Alex, yes or no?
Yes.
Yes.
Entonces, basic, I prepare for you assignments. You click here, assignment, open the assignments. And the only thing that you should do is, okay, you see several things, pero no. Focus in homework 1 for the test 1. Homework 2 for the test 1. Pre-test number 1 and test number 1. I want to explain everything now. So the important thing is the test number 1. We have here for the test number 1, we have 100 points available, no? So you fail, no. But okay, we have 20 questions. Okay. Pre-test is only for practice before the test. Okay? And no grade. You are doing the math, no problem. And the homework, yes, the homework is no mandatory, pero es extra credit. Si you are doing well, more than 80%, homework 1 and homework 2 both, you have 10 extra points for the test number 1. And little by little, test number 2, test number 3, test number 4, test number 5. And okay, some students ask me, Professor, when I open Alex the first time, I need to take initial knowledge check? No. Okay. I don't delete that because this is when you open the Alex the first time, it's like a tours that illustrate the possibility and the different technique, the graphic, how you type the expression. But if you know, because you worked before with the Alex, you skip that part. You click next, and don't worry. I don't care this. I care homework 1 for the test 1, homework 2 for the test 1, pre-test, for practice, and test 1. And model 1, model 2, model 3, no important. This is not important. This is the bank of the exercise in which I take the example. But no, you don't touch this. Okay? And systematically, when we are working with the test 2, test 3, you can see it appears new homework, new pre-test, and new test. Okay? I want to come back. Do you see or no? Clear or not clear?
Yes, it's clear.
Yes.
Okay. Remember, when I finish, I open the section and you can ask me anything. Okay, so basically, what is the formula? What is the formula to compute the overall grade? I compute the overall grade. I add in test number 1 in paper, this one, plus test number 1 online. Okay, online. Plus test number 2 on paper, plus test number 2 online, plus and so on. Test number 5 on paper, plus test number 5 online, divided by 10, no? It's the average. Okay? And completely optional, no mandatory, final test. Final test is a tool that I create to help the students. Suppose you fail, suppose we still in Alex. Oh, sorry, coño. Okay. Thank you for reminding me, Andreina. Okay. Andreina say que I don't switch in the... Okay. Andreina, okay? Do you see or no? So I explaining, guy. What is the formula to compute the overall grade? This is overall grade. Is equal, boom. You average 10 tests. We have in total 10 tests. Entonces I explain the final. The final is no mandatory, it's totally optional. Suppose one situation in which one student, when I compute this formula, get 83. 83 es obvio que es B, that the grade is B. Pero no, professor, no, I need A because I want to increase my GPA. Okay, take the final. You take the final, and I introduce the final here inside the formula. And divided by no 11 divided by 10. Okay? Suppose que worst scenario, que you are doing a mess in the final, get 0. Okay, doesn't change. You stay with me. The final is always good to take. No. So you get A in every test, you don't need to take the final. Okay? Do you understand or no?
Yes.
Final online. No, paper. I prefer paper. There, I don't know. But I normally, I prefer in paper. Yeah, I prefer in paper. Okay. Entonces, si you understand that part, you have question or no? No. Okay, entonces I want to explain. No, okay. I want to explain what is my idea and how do you study this subject. Okay. As soon as possible. I suppose que next week, our next class is Tuesday, no? Everyone is already get inside Alex. And you start doing homework. Homework number 1, no? Entonces, guys, if you stop in one question, you can anytime, at least with me, communicate with me. Professor, I don't understand that question. What is the problem? The problem is que your problem, your example, is similar objective, but it's different number. Entonces, some students at the beginning say, no, professor, do for me number 7. No, number 7 in my computer is different to number 7 and the other student and number 7 in your computer. Entonces, recommendation, take a screenshot, take a picture, and send me the picture. I solving in one piece of paper here at home in 5 seconds. I send back to you the answer. We can interchange in order if you don't understand the solution or not. Listen to me. This is the test, the homework 1, homework 2, no? And also pre-test, why no? And the test, no, I cannot help. And the test is your test. Remember, I passed this class. You have to pass. So the test is your test. Entonces, for this reason, because this subject is very, very intensive and complicated, math department in Honte Campo assigned 2 teachers. I am the main teacher, the principal teacher. But we have another teacher que es de Professor César Habano. Que by the way, is here. He's a tutor. He is with off any lecture. And also, I send to you, I do not see you receive or no the schedule of the tutor. But this is our specific tutor assigned in our class. Okay? Entonces, César or me, it doesn't matter. César is excellent tutor. By the way, he was my student, excellent tutor. Okay? So don't hesitate. Any question? I am here. 24 hours, 7 days a week. Cesar have a specific schedule. Okay, Cesar, you want to say something or no? Cesar?
Not right now. If anything, they can ask.
Cesar is here. Listen to me, anything. When you want to participate in something, Cesar, you let me know. Entonces, this lecture is recorded now. Okay, Cesar, okay. It's recorded now. I will post it in Blackboard of the Miami-Dade College and also in my YouTube channel. So we have a video, no? In Blackboard Blackboard of NDC and YouTube, because I have my specific YouTube channel. By the way, if you subscribe in my YouTube channel, we have 5 extra points for every test. For every, not online, on paper. Well, so you multiply 5 times 5, 25 points. So take advantage, You subscribe. Okay. Entonces I open the section. Do you have any question? Don't worry, guys. Throughout the semester, class on Blackboard. No. In Blackboard, I will post this video. Do you see que now it's recorded? Do you see que now it's recorded? This button, red button is available, it's because this is recorded, right? So when I finish the section, I retrieve the video. I upload in YouTube and upload in Blackboard of the Miami-Dade College. So you don't find, I can send the link. Okay, great. Important, super important online class. Communication. You communicate with me every so you check in the email every day, at least one time. And don't hesitate to ask me any question, no? See, you are missing. I don't see your attendance because I saw, okay. When this is over, the class is over, I see your name in the background. When I close Skype, I saw your name. Because I copy in my notebook the student present today. Oh, okay? So you are missing. You lost information. To see you lost one day is horrible in this class because it's 2 hours. And 2 hours is playing a lot of things. Okay. Any question? No problema. Do you understand? Okay, let's come back again to the whiteboard. And we start mathematics now. See, you have no question. Okay. Do you see whiteboard now? Huh?
Yes.
Okay, Andreina was my student. Andreina always helped me. I remember Andreina when they take the class with me. Okay, the first topic I try to cover today is about complex number. Okay. Entonces, to introduce the idea for the complex number, I want to propose this problem. Compute the square root -25. So this problem have no solution, no real solution. What means that? Why no? We have no real solution. The reason is that the all real number is a number that you can represent on this line. Okay, by the way, this line is a one-dimension object. This is infinity positive, this is infinity negative. And remember the definition for the square root. Square root is you try to find one number and multiply by itself is equal to -25. So say 1, 2, 3, 4, 5, suppose 5, but 5 times 5 is positive 25. And no good, because I need -25. Well, let me try with a -5, okay, maybe it's good. But no, because -5 times -5 is positive 25. This is the reason that square root -25, the answer of this, if exists, is not inside the all real number line. It's in another dimension. It's in another space. Therefore, to solve that problem, the mathematician create by definition, que square root -1 is I. This is symbolic, totally symbolic way to represent square root -1. So instead of write square root -1, it's too long, no, you write just I. And this is called imaginary unit. So wow, we have numbers en matemática que contain I, and we have number, the traditional number que we see whole life, que es no I, que es real. The real is the number que do not contain I, and the imaginary is the number que contain I. Entonces, come back again to the problem, square root -25. Well, I break it down like that, like a square root positive 25 times square root -1. Perfect. Square root 25, 5. This is clear. And it's by definition is I. And the answer is 5, I. And this number is obvious case imaginary number. Is imaginary. Pure imaginary. Okay. Entonces the formula is easy because you have, for example, in general, you have square roots. Any negative number, you compute the square root of the same number but positive, multiplication by I. This is the formula. Okay? Let's see one example. Suppose square root -200. Well, entonces square root positive 200, multiplication by I. And leave it like that? No, hello. We can simplification a little bit. Square root 200 because it's 2 times 100. And square root 2 is a prime number, but square root 100 is 10, no? And the answer is 10 radical 2i. Okay? Okay? It's clear, right? It's easy, super easy. Okay, let's practice a little bit. I bring some example and you help me to understand this. Example, that was example 1. Now example 2. Look, I want to complicate a little bit your life. Square root -9 times square root -9. Compute that. Oh, wow. Okay. One totally wrong thing is to try to join this radical and only one. This is the wrong idea. That you put together -9 and -9, 81 and 9. This is completely wrong. Why? Because when you see negative inside the radical, this is imaginary. It's obvious that this is radical 3, square root 9 is 3i. The answer is 3i. So the answer for the first square root. And the answer for the second is identical. It's the same, 3i. And 3 times 3 is 9. I times I is I squared. And this is the final answer, no. Why no? Because I want to prove the I squared is -1. Okay, to prove this is easy, I come back to the definition for the I, que is square root -1. If you square both sides, it's obvious que square root and square power cancel out each other. Thus the answer is -1. What is the final answer, professor? The final answer is -9. So you replace I squared for -1. And you know, -1 is invisible because the factor 1 is invisible, but stay the negative, no? It's -9. The answer is -9. Another example. Example 3. Suppose square root -64 times square root -25, like I did before. It's so because this is AI, the first one, because square root 64 is A. And this is AI, like I did before. And the answer is 40, I squared, but I squared is -1, so the answer is -40. End the story. Any question? No? Everyone follow me? Good. I like this class. No. I like because you don't ask me no. So you have questions, you let me know. Right? Okay, I want to erase everything. Good. Let me complicate more your life. Example 4. A 4. Let me see. 3, 4, yeah. Example 4. This is square root, negative 16 times square root, negative 4 times square root, negative 49. Okay, the answer is 4i, no? It's obvious, right? Multiplication, 2i, because the square root 4 is 2 and 49 is 7i. And your multiplication, 4 times 2 is 8, 8 times 7, 56. 56i cubic. And leave it like that? No. Because I need to replace I cubic, but your equivalent I cubic is a square I1. Because 2 plus 1 is 3, no? But I square I know is negative 1. The answer is negative. So what is my final answer? My final answer is negative 56i. Because I cubic is equivalent to negative I. Okay? Okay, entonces, the final answer o es real, do not contain I, o es pure imaginary, pero contain 1 power of I. No cubic, no 4, no fifth, no. Okay, one more example. Example 5. Example 5. This is square root, negative 36 times square root, negative 81 times square root. Wow, how many square root? 16 square root, negative 9. Okay, I compare it one by one. This is 6i. This is 9i. This is 4i. And this is 3i. And you put in a calculator because you can use a calculator in this subject, obviously. So I recommend using scientific calculator. It's mandatory using scientific calculator. Okay? Your multiplication, 6 times 9 is 54. And 4 times 3 is 12. And 54 times 12 is 648. And how many I we have in total? 1, 2, 3, 4. I to the 4 power. Leave it like that. No. O sea, I to the 4 power is I squared times I squared. I know I squared is negative 1. This is a negative 1. This is another negative 1. A negative 1. A negative 1 together is positive 1. Wow, unbelievable. I to the 4 power is 1. And the answer is 648. Just like that. Purely real solution. Okay. Entonces I want to generalize. Okay, I understand, professor. I understand the power of the I understand at least this column que I, you say que es square root negative 1, que I square is negative 1, que I cubic was negative I, and I4 was 1, positive real. This is the column 0. Let me call column 0. Suppose I want to continue the power of that because I want to discover formula. What is the formula to find any power? I to the 4,000. Entonces, I to the 5th power is exactly the same I. Like, it's a coincidence in the first row. I to the 6 is negative 1. I to the 7 is negative I. I to the 8 is again 1. And this part, bam, 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 continue forever. 4 by 4. Okay, 4 by 4. And this is what is the formula, professor? Okay, the formula is, look. Let me show you one example. I want to illustrate shortcut to find this in 1 second. Suppose I want to find I to the 15th power. Well, okay, professor. We continue here, column 2. Maybe column 3, no? Because, okay, this is 4, this is 8, this is 12, no? Okay, 1 again. And this is 8 to the 16, no? Okay, 1 again. And 15 is supposed to be here. 15 is here. 15 is here. Negative I. He say es negative I. FL. Say es negative I, professor. Okay. So what is the procedure? You can complete, but this is crazy. Because suppose que es 4,000, entonces you continue. No. So one procedure is, okay, I realize que any power of the I que es múltiplo of 4, like 4, 8, 12, 16, 20, 24, is 1. So I try to find the power of the I close to 15, pero down. Closest 16, pero in order to avoid negative exponent, no good. I tried S12, no? Entonces 12 times I to the third power, because 12 plus 3 is 15, no? I know automatically que this guy disappear because it's 1. Entonces I cube, y I know que I cube is negative. Okay, this is one possibility. Another possibility I like so much is you divide 15 divided by 4. Always divided by 4. Why by 4? Because the 4 by 4 is better. 4 by 4. When you divide by 4 is 3. It's 12. So multiplication 4 times 3 is 12. Subtraction. Typical division elementary school by hand. And the remainder is 3. So what is the interpretation of this? When we have 2, 3, basic coincidence in this example. This 3, okay, remainder. And this 3 gets the quotient, no? The answer of the division. I don't care this guy. I care the remainder. The remainder is exactly the exponent you keep. So automatically you say 15 is equivalent I to the cubic. I don't care this part. This 3 is this 3. You take a picture, right? And this is negative. This is a shortcut. Let's practice a shortcut. I bring 1, 2, 3, 4. Okay. Problem of the power of the I. And you let me know if you understand or no. Suppose I to the 18. Okay, professor, I like that way. Let me try. 18 divided by 4 is 4, no? Because 5 is too much. Entonces 4, que es 4 times 4, 16, subtraction es 2. Entonces I discover que es equivalent a I square, pero I square es negative 1, que es real. This is one example. I to the 20. 20 divided by 4. Oh, it's 5. It's 20 and remains 0. Oh, the reason is clear. Because 20 is a multiple of, exact multiple of 4. So si es exact multiple of 4, I know that the answer is 1. Pero suppose que I don't remember. Entonces, I to the 0. Y I know que any number or expression raised to the 0 power is always 1. It's a classical in mathematics. Suppose I to the 9. I to the 9 is easy. Let me see in the table. I to the 9 is here. I to the 9, no? I suppose que es I. I suppose, I don't know. So you divide 9 by 4. It's 2, it's 8. Remember 1. Okay, it's I to the 1. But you know, 1 is invisible exponent. It's just I. Okay, one more, and that's it. 53. I to the 53. 53 divided by 4. By hand, no calculator, because in calculator you get decimal. I don't know exactly what happened with the decimal. Entonces, by 4 is 1, no? Because 1 times 4 is 4. Subtraction is 1. Bring down 3, 13. 13 is 3, no? Because 3 times 12. Remember 1. I don't care the rest. The important information is this. It's again, Exactly the same of this. I to the 1 power is 1. Do you get the idea or no? Do you get the idea or no? Clear or confusing? Super clear.
It's clear, yeah.
I promise I want to complicate more your life. When you have negative exponent, pero no now, no now. Pero yes, today, yes. Remember, our class is very, very intensive. You take good breakfast today or no? I suppose. No, lady said, no, I don't. Okay. So you have time, go to the kitchen and take something, no? Throughout, I explain. Okay, let me try now, change a little bit the flavor. I go to the, well, okay. We talk about real number and imaginary number, but the combination of both is a complex number. What is a complex number? Well, complex number is the combination of real and imaginary together. Example to understand this. Suppose this 4 plus 3i. This is a complex number. This entire is a complex number. But 4 represent the real part. And 3i represent the imaginary part. Okay? Some particular example. Suppose 4 alone. 4 is a complex number. Well, yes. But actually 4 is purely real. And 3i alone is, yes, it's complex. Complex is more generic a concept, but it is purely imaginary. And together, well, together is a complex. The not purely real, not purely imaginary is a combination. Okay, so let's study now several arithmetic operations using complex number: addition, subtraction, multiplication, division, power. But before this, I want to define one thing is called a conjugate. Conjugate. It's important concept, conjugate, in complex number. Conjugate is the notation that we're using for the conjugate. Suppose, again, the same example. I like so much this example. You put a bar here in the top, and this bar represents conjugate. The conjugate is exactly the same, but the imaginary part have opposite sign, minus 3i. Okay, the real part stay the same, exactly the same number and sign, and the imaginary part no, change the sign. This is called conjugate. Yes, this is important in the operation we studied now. Okay, conjugate. Remember the conjugate, we use it now. No, exactly now, right now, in a few seconds. Let me try to explain addition. Super easy, straightforward. Suppose two complex numbers. 4 plus 3i plus 2 minus 5. So we're adding two complex numbers. Okay, so I recommend remove the parenthesis. 4 plus 3i plus 2 minus 5. And we combine later. Real part, 6. Imaginary part, 3 minus 1 is 2. End the story. Super easy. Remove the parentheses and combine real, imaginary. Subtraction, exactly the same or similar. Why not? The same example, 4 plus 3i minus, but in this case, minus subtraction. So you remove the parentheses again, but be careful when you subtracting the subtrahend, change the sign. So this is stay the same, but now change. It's minus 2 plus I, because this minus affect everything inside the subtrahend, which is the second complex number, no? And you combine real, 4 minus 2 is 2. Imaginary, 4i. Any question? Super easy. In the test, I like to put the one question like that. Well, okay. It's unbelievable que some students fail that question because the student try to do like a multiplication. No, addition or subtraction. You take care of the arithmetic symbol. No? Okay, let's say multiplication. Multiplication is a little bit more complicated. Multiplication. Suppose again, why not? 4 plus 3i times 2 minus I. And when you see parentheses and default, you suppose that this arithmetic operation is time, not necessarily specification, period, in the middle. No, not necessarily. Everyone understands it's time. And you interpret it like a binomial, and you apply FOIL. 4 times 2 is 8. 4 times negative I is minus 4i. 3i times 2 is 6i. And 3i times negative I is minus 3 I squared. And one more time happen that you don't leave like that. Illegal violation. I squared replaced by negative 1. I know very well that I squared is real as negative 1. Entonces 8 minus 4i plus 6i. Well, so you replace this by negative 1. I do mentally. I know. Look. In my mind, in my way is, I know, okay, I square negative 1 to say negative 1 and another negative we have in the front become positive. End the story. This is my shortcut. No? I'm ready to combine like term. This is a real 11. Imaginary is 6 is positive minus 4 is 2. Right. End the story. Okay. It's important. When you solve an operation using complex number, the final answer is expressed in that way. It's called a standard. A standard form of expressing complex number. What is the standard? You copy first the real part. And you copy secondly, imaginary part. Okay? Some people, I don't know, prefer put the I first, but it's ugly. I don't like that. Okay? Depending si es whole number or not. Okay, this is multiplication. Do you understand very well multiplication? Okay, but we have one special, super fantastic special case of the multiplication complex in which you multiply any complex number. Again, we're using the famous example. I like so much, I don't know why. Multiplication by its conjugate. Okay, this is the conjugate. Okay, entonces some important suddenly situation happen when you multiply any complex number times its conjugate. Number one, the answer is real. Unbelievable. The answer is real. Disappear the imaginary part. And secondly, you see. Entonces, I don't know anything. Again, I apply for professor because I don't know the shortcut that you talk about. I try to do by the old-fashioned way, que es multiplication 4 times 4 is 16. Okay, good. 4 times is minus 12i, because 4 times 3 is 12. It's imaginary, contain I. Now it's positive 12i. Okay, and finally is minus 9i squared. Wow, look at that. Always happen, that situation. The imaginary part is gone, cancel out, disappear. And we have 16. 16, in this case, remember, I squared negative 1, another negative 1 we have in the front is positive, and the answer is 25. Wow, amazing. The answer is, when you multiply, always happen. It's a special problem. When you multiply any complex number times its conjugate, the answer is real, no imaginary. Okay? And we take advantage of this fact in your moment. No. Okay, so what is the formula? I don't understand very well, Professor, the shortcut. Well, the shortcut is, if you multiply any complex number, let me call in general A plus IB. Okay, A is the real part, BI is the imaginary part, time is conjugate, Unbelievable. The answer is a squared plus b squared. Okay, this is exactly the same proof that we did here using number, pero using letter, no? If you want, I do it again, but not necessary, no? Multiplication, a times a is square. Entonces, this is look like similar to the formula that we frequently use in intermediate algebra, que es a plus b, a minus b, is equal a squared minus b squared. It's the famous difference of a square. But this is the extension for the complex number. When you have I, this is plus. Unbelievable. 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 Okay, let me see you understand very well or no this special multiplication. Suppose que I multiply 2 plus I times 2 minus I. I need help. Help me, please. What is the answer of that? Come on, quickly. Using the shortcut we are doing in 2 seconds. Nobody. Nobody help me. Ah, wow. Guy, a 4, no, it's not 4. To get inside the Skype, don't use a nickname, using your own real name, because I don't know who is live. CB753F. What the hell is that? So what's the answer? Nobody get the answer. Yalin, Lady, Andreina, 5, es obvio que 5. Lady dice que 5. Let me show you. Why? F5. C what? 5I, no 5I. F5. Listen to me. I explain that when you multiply any complex number times its conjugate, the answer is real. This is totally illegal to put here 5I. 5I, no. Entonces es basic. What is shortcut? The shortcut is you multiply 2 times 2. F4. Always plus, look at that. No minus, because it's imaginary, complex, sorry. And the coefficient here is 1. And 1 times 1 is 1. The answer is 5. One more. 1 plus I times 1 minus I. Who help me? Come on. Who help me? No. 2. Very well. 2. The answer is 2. Okay. You need to know that the answer is always real. You copy 2I, 0 for you. Okay? The answer is always real. And you multiply 2 times 2. 1 times 1. And again, invisible 1 is 1 plus 1. One more. 1 plus 3I times 1 minus 3I. Who help me with this? Come on. Dang, very well. You get the idea. Okay, smart guy. You get the idea. The answer is 10. Entonces, professor, pero in what part are you using this? Oh, you will be using this in the division. Let me explain division now. Division complex number. Division. Okay, let me try division. Division is, suppose example 1 of the division is 4 plus 3I. You are dividing this complex number divided by 2 minus I. Okay, division. To perform division, it's always the same procedure, always. you multiply. So this is my original problem, okay? But I create artificially one other fraction. In the second fraction, we have the conjugate of the complex number in the denominator. And the complex number in the denominator is 2 minus I, but the conjugate is 2 plus I. So in order to doesn't affect my original problem, you divide and multiply by the same. So this is, you can interpretation like this guy, que totally artificially, pero help me to solve the problem, is called like a smart one. Smart one because any expression divided by itself, you know que one is invisible in algebra. However, help me to solve the problem. So now this is the challenge, multiplication this in a complex number time this and this. That this and this. Okay, it's easy because it's a special product. It's 5, no? We did before, no? It's 5. 2 times 2 plus. Always plus. Unbelievable, but it's true. Some people go and say, no, professor, pero it's positive and negative, so it's negative. No, because a square and negative together become positive. And the top, no. And the top, there are no family, no conjugate. And you apply the regular FOIL. Is first 8, outer for I, inner 6I, and last, que is 3I. 3I square, no? Because we have double I, no? Leave it like that, no? Of course, no. We continue working. Because I know the I square is -1. So immediately I replace A plus 4I plus 6I minus 3, no? Divided by 5. And leave it like that? No, of course, no. Because we combine like term real. So A minus 3 is 5. And imaginary part, 4 plus 6 is 10I divided by 5. And leave it like that? No. Remember, standard form. So you split this common denominator, 5 divided by 5, que es obvio que es 1, and 10I divided by 5, que es obvio que es 2I. Entonces, the answer is 1 plus 2I, and this is my beautiful final answer. Do you see, guys, que I enclose in the box always the final answer? It's the thing you should do in the text, on paper. When you finish doing something, you put in the box the final answer. Any question? No problema. You feel strong? Okay, this was division, but I have one more example. Why not? Suppose this example, 10 divided by 1 plus 3. Oh, in this case, different because, well, no different, it's the same. You have 10, que 10 is a real number divided by 1 plus 3, I guess is a complex number. Okay, but it's the same procedure. You multiply it by the smart one. Okay, our smart one in this case is 1 minus 3i. 1 minus 3i. Okay. Entonces, everyone know very well que the answer here is 10. 1 times 1 is 1. Plus 3 times 3 is 9. 1 plus 9 is 10. And the bar. And the top is just distributive property because this is a monomial. This is 10 minus 30. I. And leave it like that? No. Split the common denominator, 10 divided by 10 minus 30i divided by 10. The answer is 1 minus 3i. Wow, easy, nice. I like division. Any question about division? Do you understand very well or no? I promise in the test. Well, okay. Do you see in the syllable? So you see the syllable. I dedicate 2 lectures, complete lecture, 4 hours to redo again everything. I go fast, but I stop. Yeah, go over again to everything. And the most important example, very, very similar, no equal family, no twin brother, to the example that you can see in the test on paper. Any question, guys? Okay, so let me come back again to the power of I. Wow, but Professor, you see before power of I. But I want to see with the negative exponent. Power of I again. Power of I, but with negative exponent. Because in the test, I don't have idea si I put negative exponent or positive exponent. Okay? Suppose I to the negative 9. Wow, what the hell is that? Do you remember what means negative exponent? Do you remember what means negative exponent? Come on, guys. Do you remember what means negative exponent in algebra? Negative exponent means something. What is the meaning of that? Nobody remember negative exponent? Wow. What is that? No idea. No idea. Reciprocal. Flip it over. Reciprocal. Okay. Alain, putting off microphone. Okay. When you see negative exponent, automatically you convert to positive, like that. 1 over I to the 9. Flip it. Reciprocal. Now I know very well how we compute the positive exponent. Remember 9 divided by 4 is 2 is 8, remain the 1. Entonces I know that this is equivalent to say 1 over I. Because the exponent is 1, que es invisible. And leave it like that. No. Remember, no. Why no? Because we need to express the final answer using a standard form. And a standard form is no expressive like a division. No. What the hell? No. So you are in front of the one problem of the division right now. Right now. And I is the complex number in the denominator. And the conjugate of I is negative I. Remember the definition. Let me see clear. What is the idea? I is pure imaginary number. Okay, we can represent like a 0 plus 1I. Because I have no real part. And so we can represent. So you are doing conjugate, is equal 0 minus 1I. And obviously, negative 1I is negative I. That is the reason that this is the conjugate of this. And when you multiply 1 time any number is exactly the same, but here is negative I squared. Okay? But I squared, I know that negative 1 and negative 1 and another negative 1 in the front become positive. Positive 1, no? Entonces negative I divided by 1. Pero division by 1 is nothing, it's invisible. The answer is negative I. And this is my elegant final answer. Any question? Power of I when the exponent is negative. There's a new thing we are studying now. Super good or super bad? Okay. I to the negative 13. Exactly the same. Negative 13. Sorry. Reciprocal. 1 over I to the 13. Go ahead. Complicated. Why complicated? Car. It's a non-complicated piece of cake. What is the problem? Right? What is the problem? Activate the microphone and ask me a question. What is the problem with the negative exponent? Negative exponent, you need to know in intermediate algebra, okay, I suppose you took before, maybe you took several years before, but no, okay. Negative exponent is reciprocal. It's the interpretation for the negative exponent. So when you have I raised to the negative 13, this is exponent, you understand that this is reciprocal. Flip it over like that. And 13 divided by 4, what is the complicated part? I don't see the complicated part. This is 3, no? 3, 3, 3, 3, 3. This is 12. Subtraction is 1 and remainder is 1. Entonces 1 over I. 1 over I. Entonces exactly the same of the other problem, ¿no? Now let me see the other problem. The other problem was, entonces you multiplication, I don't want to do it again, it's negative I. Okay, one more. The last one of negative exponent. I to the negative 11 is 1 over I to the positive 11. Reciprocal. 11 divided by 4 is 2, no? 8 is 3. So this is equivalent to say 1 over I cubic. But I know very well que I cubic is negative I. Now multiplication by a conjugate, que in this case positive I. So positive I divided by, I did before that part, is 1. The answer is I. End the story. Piece okay. Super easy. Got now, thank you, no problem. It's my pleasure. I enjoy explaining. For a student like you, que want to know, que want to learn. Okay, guys. So now let's doing a little question about the power of I. But no exactly power of I, sino power of the any complex number. Suppose this idea, look at that. Suppose, let's do in this example, que es a power, pero power of the complex number. Suppose que es 2 plus 3i. Right to the second power. Let's do in this example, and why not one a little bit complicated using irrational number, que es radical 2 over 2 plus I radical 2 over 2 square. Well, si es a square is easy because we can break it down this like this, 2 plus 3i times 2 plus 3i. Si es cubic, entonces it's too long. Porque you need to multiply by the third one, entonces it's more complicated. Pero no, let's I never put cubic power, 4 power, it's crazy. This is easy, but it's too long. It's the only complication. And you foil, and end the story. But this is different to the conjugate. In conjugate, you expect that their answer is real. In this case, no conjugate. They are twin brothers, exactly the same. When you foil, 2 times 2 is 4. This is 6. This is 6, identical, twin brother. And this is 9. I squared. Remember, personally, guys, I never write that like that. I erase this. I put negative directly, no? Because I know I squared negative 1. And you combine real part, and negative 5. And combine imaginary part, 12. End the story. I finish. This is really interesting, very interesting. Because the answer that you get when you finish is really amazing. It's really surprise. Okay. I have no idea. I trade by the regular way. You multiply this. Multiply by itself, no? But I take advantage that we have repetition, the number, no? Because when you multiply radical 2 over 2 times radical 2 over 2, let me try to do here. I copy in one corner of the piece of paper. Radical 2 over 2 times radical 2 over 2. Bueno, radical 2 times radical 2 is 2, no? And 2 times 2 is 4. Reduce and lower term, 1/2. Wow, it's 1/2. So when you multiply everything, it's 1/2, 1/2, 1/2. Because this is 1/2, okay? When you multiply this and this, it's also 1/2, pero I. When you multiply this and this, it's the same. But when you multiply this and this, it's 1/2 again, pero I square. because 2i and I squared -1. Entonces, -1/2. Wow. Look at that. When you combine real part and real part, it's cancelled out. And when you combine imaginary part and imaginary part, 1/2 plus 1/2 is 1. And the answer, unbelievable, is just I. It's just I. Okay, not bad. Okay, let's change the flavor now. Remember, guys, this is too long class, 5 credit class. You stretch a little bit. Okay. Image. You want to screenshot? Let me know. And make a zoom. Can you take the good screenshot? Professor, communicate, guys. Communication is important because we are remotely, no? Entonces, communication. Don't hesitate.